A, which is negative 9.8, times delta S, which is negative 20. And by the way, the dot here between the A and the delta S, that is there on purpose. It should be a dot. It's not just straight up multiplication, it's a dot product.
Is that like,
Pardon?
those are different?
Yeah, there's two types of multiplying with vectors. One is dot products or scalar products.
Okay.
The other one is a vector product or a cross product.
Okay. I've just been using the dot my whole life and I thought that meant multiplication.
It does mean multiplication, but if you drop the dot there, then this actually is a nonsensical thing. Because
okay.
since there's two different ways of multiplying vectors, you have to specify which one. This one's a dot.
Okay.
All right, so someone would be kind enough to write through this.
Square root of 1,292.
1,192,
292.
which is
35.9444. 0, 1.
you're misinterpreting my look, but we can go 0, 1 if you want, but.
Okay. 5, 1.
I'm still taking 3 points off on the 10-point problem.
Should just be the,
Or would you keep, do you want us to keep it in the square root?
No, I'd rather see the number
I was
first.
just asking for the units.
oh.
Oh.
Yeah.
Meters per second, yeah.
Yeah, there we go.
Okay.
And you did say that you don't care about sig figs, do you?
No, not,
Okay.
well, not at all this semester. Usually it's only for that very first lab. But on tests, quizzes, no, there's enough other things to consider, worry about. All right, I wouldn't take it out that many decimal places, but, nothing wrong with it. Assuming there's no mistakes anywhere. Okay, so you could have made the argument that we don't need the units yet because we haven't actually answered the question. What is the answer to the question? That's our final speed. The question is, what's the final velocity?
It would be negative.
Yes.
Negative 35. Oh, that.
Why is it negative?
Because traveling downward,
Yes.
and the up direction's positive.
Yep. The sign of velocity depends upon which direction it's moving. And for those who are still struggling with my handwriting, that is an F there. All right, time.
You could, well, since we have velocity final, I guess you could solve for time by using the velocity, like the first equation.
All right. Yeah, and matter of fact, we could solve for time using any one of these, anything other than this one. All right, so I have negative 35.944, etc. equals 30 plus negative 9.8t. Okay, solve for it, so this becomes negative 65.944 over 9.8. Negative 9.8.
I got 6.729 seconds.
All right.
That's not that bad. Once I guess you figure everything out. It looked intimidating to me at first.
Step by step.
Yeah.
We could have solved for time first. We don't know final velocity, but we could have solved for time using this equation right here. Let's go ahead and do that, just to show that we'll get the exact same answer, but we'll get two answers, and I want to talk about what the second answer is, what it means. So if we plug into this equation here, you get negative 20 is equal to 30t minus 4.9t squared. 1/2 times 9.8, that's where the 4.9 comes from. I have a quadratic equation, and how do we solve quadratic equations the simple way?
By using the quadratic formula.
And so what do we need to do to get it into quadratic formula, to get it ready for quadratic formula?
Add 20. No, probably not actually.
Yeah, make it equal to 0.
Yeah.
Okay, so adding the 20 will do. This is my own personal thing. There's nothing wrong with adding 20 to both sides. For whatever childhood trauma, I like the first term to be positive, and that's a me thing. So I'm going to bring everything over there.
Oh,
You know what? I can do this. I can do it.
okay. I can.
I'm going to add 20 to both sides just to show that if I suddenly go into a fetal position, then this is not
Your
right.
childhood self would be so proud of you right now.
Brag to my therapist. All right. And so now, lug and chug. So now, I'm not expecting you to have it. There's sort of a mix on expectations. I'm assuming that most of you know the quadratic formula without singing the song. Please don't.
Is there a song?
There is a song.
Yeah, it's very bad.
I have to-
Stop. I shouldn't have brought it up. But it'll also be at the top of the first page of the test or quiz. I mean, I'm not expecting, you're not required, that's better. You're not required, even though I sort of expect most of you know it. All right, so time is equal to negative 30 plus or minus the square root of 30 squared minus 4 times a, negative 4.9, times c, divided by 2a. And if I'm not mistaken, I think one of the answers is somewhere around 6.729 seconds, somewhere around there.
That's what
But
I got.
something like that. You feeling?
I just solved that, yeah.
Yeah.
That's what I got.
It's great when you can solve square roots like that. Us and Artie Benjamin. All right, so we do get two answers. T equals. I am assuming that that number is right. And the other one?
Negative 0.6065. That's seconds.
What does that negative answer mean?
Oh, good.
Nothing.
Oh, no, what does that mean?
I wanna. No, that wouldn't be right. Maybe?
Go for it. Worst that happens is that you're wrong and the world will see.
I wanna say that it's the time it takes the ball from the guy's hand to reach its peak, which probably isn't it.
It is not.
Okay. Wait, that wouldn't even make sense. That's a negative. How do you get negative time?
It happens before you start the stopwatch. That's all the negative time means. It happened
Oh,
earlier.
okay.
Think about the blending of math and physics. We have solved a math problem here. Physics got us, well, sure, we'll call it physics, gets us this far, and then it's a math problem. What problem is the math solving? If I put y equals in front of this, what would this graph look like?
Parabola?
Yeah,
Yeah.
So what we're dealing with here is a parabola that looks like that. And what we're doing is finding the zeros here. We're finding these 2 points. So what we have found here is if the ball had been shot from this spot right here, it goes all the way up and down so that at this point it's going 30 meters per second. How much time did this take? That's what it solved. So that would be sort of, it's not the correct answer because it happens before we started the problem, but that would be a physical meaning of it.
Okay.
Sorry, could you restate that one more time?
All right, so what the math sees is a parabola, and we're trying to figure out where it's equal to 0.
Yeah.
Okay. So we have 2 answers here. This would be, this is my time axis, and call it y. Or actually, delta s. So this time right here is 6.729 seconds. That's, so the thing is shot up and it comes back down, hits the ground.
Perfect.
This point right here is the negative 0.6065? Yeah, 6065 seconds. So this is the time, if we had shot the ball up from the ground, instead of starting 20 meters above the ground, above the bottom here, if we shot it from here to go up and down, so that it's going 30 meters per second at this point, when it's 20 meters above.
Oh, from the ground where it stops.
Yes.
Okay. Wow.
So that's, that point, 6065 seconds is how long it would take the object to get from here to here.
So the ground is on the time axis, basically, a math kind of.
The ground is on the time axis? Yeah, in a sense.
Sitting on, okay. That's a weird question, but.
If I understood it, yes, I agree with it. All right, take a long pause again for questions.
Are we gonna do like any problems we are not on Earth? We're like,
Yep.
okay.
What would you, if I threw this onto Mars, what would change?
The gravitational acceleration.
Okay,
Yeah.
and what would the value be?
That's a great question.
-4.
I think it's 3.7. It'd be negative 3.7 meters per second squared.
That was close.
Now, as a double check here, we have this thing being shot up and coming back down. We have, for my 2 times here, we have a larger positive time and a smaller negative, absolute value of the negative time, which makes sense for something that's being thrown upwards. If we had come up with them flipped, so I had 0.6065 seconds positive and negative 6.29 seconds negative, that situation would be something like that, where it is being thrown downwards.
Oh, yeah.
So if we had gotten some minus signs off, I think if that one had been off, we would have gotten them flipped. So, if we had gotten the signs opposite of what we have down there, then hopefully you're in the state of mind where you're going, wait a second, that doesn't make sense. Just like over here, when I divided by, I originally wrote 9.8, and then I realized, wait, we'll get a negative time. That does not make sense. And then I realized, oh, I forgot. Silly math error. If you end up with a minus sign someplace you don't expect, don't automatically just go, oh, we'll just make it positive. For example. We'll keep that. That will change. That changes. No, that stays. That goes. I want to know the time when all is meters meters above starting point. So this is now 100 meters.
Is that possible?
Let's see what the math says. All right, so this is what we're dealing with. The only thing that's changed here is the negative 20 becomes 100. And so VF becomes the square root of what?
The square root of negative 1060.
That you can do that. That's
What
a.
do you mean you can't do that?
Yeah, that's a imaginary. That's a
Okay, so you can do it, but you get an imaginary answer. So there's two things that the minus sign will tell us. One, the problem's impossible, or two, we made a mistake somewhere. I think I know which way Kent is gonna go. I assume you're gonna vote for it's not possible.
Yeah.
It's not possible.
And so then think through it, go, all right, does this make any sense? If I throw something into the air, is it possible that it won't reach a certain height? Yes, that's possible. So, in this particular case, I'm feeling confident that this means it's not a possible answer. Do not, I've said it before, probably in several videos, don't get the negative under the radical and go, oh, I can't do that, so let's just get rid of the minus sign.
Oh.
That is just painful to grade. You're doing everything right, and then suddenly you get to that and you go, wait, my calculator can't handle it. I assume my calculator can, I don't know if yours can. The TI-80 whatever deal with complex numbers?
I no.
Not my edition.
I no.
Okay.
They kind of just yell at you.
Some of your calculators can't handle it.
No, I can't.
And, oh, there it is. All right, questions before we up the game and actually get into what I wanted to talk about.
In that first scenario, why was the position negative 20 instead of 20? Positive 20.
All right, so this was displacement,
Yeah.
which is where an object is relative to where it started.
Okay.
So where does it end up relative to where it started?
Above. Wait, no. That below.
Yes. In the original problem, it ends up below
Yeah.
where it started.
So that'd be negative 20.
Because I said up was positive.
Yeah. Okay.
Yes. Other questions before I erase part of this? Now, I know I've done a video on the next thing I'm gonna talk about, and I'll use different numbers, but I assume. But I wanna at least make sure we've got it based down before we start playing around with it. So back to this. This time it's thrown at an angle. So initially at 50 meters per second, an angle of 37 degrees. I want to know, how far out does it go at the base of this cliff? It's now a two-dimensional problem, and so we need to be aware that, first off, what's the direction of acceleration? Once it's left the hand, what's the direction of acceleration?
37 degrees perpendicular to positive.
Right, to the right.
Pardon?
Going to the right.
Something to the right?
No, like it's going to the right.
We know that.
Yeah, it's being shot up like that.
Like that, so it's gonna go
Yes.
in a positive direction.
Yeah, so for those who need the visual. Sorry, that was closer than I intended,
Yeah.
but I didn't hit you.
I like those visuals.
That was pretty cool. Because I'm sure none of you have thrown stuff before, so that,
I don't know if it followed it perfectly.
it just didn't match that 50 meters a second.
So,
I think even in my prime, I couldn't get to 50 meters a second. It's over 100 miles an hour. Oh, no, definitely, I could not get. In my prime, I'm not sure I could get 50 miles per hour either. All right, so, direction of acceleration, that's where the question was. Once it's left the hand, and I know we haven't really discussed forces, but I'm hoping there's enough residual memory. What are the forces acting on this as it's in the air?
Gravity.
gravity. Oh, the
Acceleration.
acceleration. of gravity.
Force.
Acceleration.
Acceleration is not a force.
Oh. Force of gravity.
Yeah, there we go, force due to gravity.
Force, dude.
Otherwise known as, in this situation,
G.
no,
Acceleration.
Are you looking for a formula?
no, I'm looking for the other word for force due to gravity
Oh.
in a situation like this.
G-force. No.
Gravitational force? No.
No, you're getting all fancy, you need to bring it down. It's a word you probably learned when you were just barely out of diapers.
Down.
Down. The opposite of up.
Wait.
Wait,
The
wait.
weight.
We should have got that.
I've asked students questions before where what's the force due to gravity acting on an object? What's the weight? And getting different answers because for some reason there's this disconnect. Force due to gravity is the general term. Weight is specific to if there's a small object and a huge object like planet size, and small relative to the huge object. That if it's the small object's near the big object, the force is called weight.